Hello students, in this video we'll discuss how to compute distances between points and lines and points and planes. So let's consider a line ax plus by equals c and a point x0, y0 not on that line. Now what we can note is that if our line looks like this is our line ax plus by equals c. If I give you 2 points on this line, say that's x1, y1, and say this point over here is x2, y2, then the direction of the line, v, will be x2 minus x1, y2 minus y1. And so now notice that also from this equation of a line we have that a x2 plus b y2 is equal to c, and a x1 plus b y1 is also equal to c. Subtracting these equations, I can conclude that a times x2 minus x1 plus b times y2 minus y1 is equal to 0, or the vector ab dot x2 minus x1 y2 minus y1 is equal to 0, which says that the direction of the line dot the vector AB is 0. So this vector AB is normal. So AB is normal to the line. So if AB is normal to the line, that means that this direction over here, if I draw a perpendicular, that is the direction of the vector AB, perpendicular. So now let's use this information to solve our problem. So now, if I'm given a line, here's our line, ax plus by equals c, and here's a point, x0, y0, which is not on the line. I'd like to find this distance over here, this perpendicular distance. I'd like to find that distance, d. What I'll do to do so is I will pick any point on the line. Let's call that point over here x1, y1. That's actually on the line. And I'll look at this vector over here from x1, y1 to x0, y0. And then I'm going to draw this vector over here. Draw this vector, the perpendicular vector. This is my perpendicular vector. That's my normal AB. And what I'm going to do is I'm going to take this vector over here. Let's call that vector over here vector w. So vector w is going to be x0 minus x1, y0 minus y1. And then I'll take that vector w and I'll project it over here. So this is the projection of w onto the vector AB. Now, we know what the formula for the projection of a vector onto another vector is. We know the projection of a vector v onto a vector w has the form v dot w over the length of w squared w, and the magnitude of the projection of v onto w is the absolute value of v dot w, all divided by the length of w. So what we'll do now is the length of the projection of w onto AB, so the length of the projection of w onto the vector AB is the distance from x0, y0 to the line L. So what will that be? So this, according to this formula, this is going to be equal to, this distance will be equal to v dot w. So that will be AB dot x0 minus x1, comma y0 minus y1, over the length of w, in this case, which is AB, so that's going to be the square root of a squared plus b squared. And so if we do this dot product, what will we get? We're going to get ax0 plus by0, ax0 plus by0. And then I'm going to have negative ax1, negative by1. But negative ax1 minus by1, well, I know that ax1 plus by1 is equal to c since it's a point on the line, so this will be equal to negative c. So I have a negative c over here, all divided by the square root of a squared plus b squared. And this is our distance formula to compute the distance between a point x0, y0 and a line ax plus by is equal to c. Thank you very much.